Hey everyone, welcome back to another video of our Java Collection Framework playlist. In this video, we will be taking a closer look at the list interface and its various types, as well as doing a hands-on demonstration of some of the main collection methods which we have learned in the last video with the ArrayList. So let's dig in. First of all, let's talk about the list interface. List is an interface in the Java Collection Framework that extends the collection interface. A list is an ordered collection of elements, which means each element has a specific index in the list. Some of the common implementations of list interface are ArrayList, LinkedList, and vector. Let's take an example. Consider the given list of numbers. Here, you can see each number is at a particular index. At index 0 we have 1, at index 1 we have 55, at index 2 we have 19, at index 3 we have 21, at index 4 we have 55, and at index 5 we have 8. Let's take another example. Consider the list of names. At index 0 we have Ram, at index 1 we have Lakshman, at index 2 we have Bharat, and at index 3 we have Shatrughan. In the above two examples of list, you can see each index has its own item, and we can implement the list using ArrayList, LinkedList, and vector. Well, so this is all about the list, and I hope the concept of list is clear to you now. Now, let's dive deeper into ArrayList. ArrayList is a class in Java that implements the list interface. It provides a dynamic array that can be used to store elements of any type. The size of an array list can be dynamically increased or decreased as needed, just as we talked about it in the previous video of Collection Framework. If you haven't watched it, you must go and watch it for the better understanding of the array list, especially the dynamic memory concept. Now, we will be doing a hands-on demonstration of the collection methods with ArrayList. We will be covering methods like add, remove, get, set, and more. You will see how these methods work and how they can be used to manipulate the elements in an array list. So get ready with your Java IDE so that you can follow along with the hands-on demonstration. Let's get started. Okay, so here I have created a basic class tester1 and a basic main function, and I have commented all the functions which we'll about to see in the few minutes. The first thing which we need to do is import java.util.star. Now let's create the list using ArrayList. We are going to create a simple number list. So this is the place to enter the object on which you are working. As we are about to work on numbers, so we will use integer. If you are going to work on string or character, you need to put that thing here. Now let's add elements to our list. So for that, the syntax is list name dot add, then the element 10 dot add 3 numbers dot add 57 numbers dot add 43. I think the 4 elements are good. Let's print our list. So for that, system.out.println list of numbers Here we got our list of numbers 10, 3, 57 and 43. Now let's add an element at a specific index of the array list. So here we have 10 at 0th index, 3 at first index, 57 at second index and 43 at third index. Let's add 100 at first index. Okay, So numbers dot add 1 comma 100. Let's print our updated array. Updated list of numbers after adding element at a particular index. So you can see our updated list 10, 100, 357 and 43. Now let's remove an element from our list. Let's remove 3, which is at index 2. Let's print our updated array. Updated list after removing an element. So we have deleted our number 3 from our list. Now let's find the size of our list. So for that we will use list name dot size. So you got the size of the list, that is 4. Now let's check if a particular element exists in our list or not. Let's check 5 exists in our list or not. Exists or not. So for that we use our list name, then contains, then object which we are finding. Obviously the answer is false, and that's what we get. Now let's check another number. Let's check 100. Oh, sorry. So 100 exists in our list. Now let's find the minimum element in the list. So for that we will use collections dot minimum, our collection name, that is numbers. So here we got the minimum element of our list, that is 10. Now similarly we can find the maximum element of our list. Collections dot max name of the list so the maximum element in our list is 100. Now we can even sort our list. For that we can use collections dot sort and the name of our collection, that is numbers. Now let's print our sorted collection. So here we got our sorted list 10, 43, 57 and 100 in the ascending order. Now we can even clear all the elements from our list. For that we need to use our list name dot clear. Very straightforward. Now let's print our list now. You can see we have got the empty list. Now let's take a glimpse of the 2D list. These were all the functions, basic functions for the 1D list, which after using this, most of the works will be get done very easily. Now let's take a glimpse of the 2D list. Before that, you must know the visualization. Visualize a simple list. Okay, now instead of putting a simple integer, you put another list at every index. Okay, visualize a simple 1D list. Okay, now at each index put another list. There we get the 2D list. Visualize in this manner, and then let's write the code here. This is our basic code of the list. Now we need to input the object on which we are operating. As I've said, visualize object as a list. Okay, so we will put another array list. Now in that array list we will put integer. We will use integer as our input. So here we have put integer in our code. Okay, this is the syntax, basic layout. Now if you want to go 3D, then instead of putting integer, you declare another list in the each elements of the 2D elements. Okay, now visualize it in this way. First visualize a single list. Now for making it 2D, you put we put a list in each element of the single 1D array list. Okay, now to make 3D list, in each element of 2D list you put another list. Okay, in that fashion you can increase it to whatever number of Ds you want. Okay, now let's add rows, after which we can put elements in each rows. Okay, So a dot add, here we need to add obviously ArrayList, because the inputs of our first list is ArrayList. Okay, so we will declare it in this manner. Now a dot add new ArrayList. Okay, so we have created 2 rows. Now let's add elements to each rows. As it is a list, so it is a variable size. You can have 1 element in a single row and 2 elements in another row. You can have 5 elements in next row. That is up to the need of your need. Okay, so let's add a dot, first get 0th row, then in 0th row add first element 23. Again let's get to 0th row, dot add 65 as per your need. Okay, now let's get to first row and add 54. Let's get again first row, dot add 21. Get 0th row and add 98. It's up to your need. Okay, now let's print our 2D array list. So here we got our 2D list of numbers 23, 65 and 98, and 54 and 21 in the second row. Now you can see each elements of the first list is a separate list. Okay, now you can use all these functions of 1D list in each elements of this first list. Okay, if you consider it first 1D list, then each element will be a list, and in each element you can use all the functions which we used in the 1D list. Okay, so for example, let's find the max element in the first row. Okay, so for that we can use max element in the first row of 2D list. That is this 23, 65 and 98. Answer is 98. But let's find it with the code. A collection dot max a dot get the 0th row. Okay, so this is the way in which we need to write the code. And we got 98, the largest element in the first row. And so that's how we work on 2D arrays, 2D array list, 2D list and 1D list. And you can even proceed further. You can move to 3D list, 4D list and 5D list as per your need. Great, so we learned about list, array list, how to implement list using ArrayList, methods to operate on ArrayList, 1D and 2D ArrayList. Well, so that's it for this video. In the next video, we will learn how to implement list using a linked list. Thank you.